Let's do a few exponent rule problems. We're going to do some of these kind of quickly. These are just trying to give you an idea of what's going on. And by the way, we'll use rule 4 quite a bit. In fact, 3 and 4 will almost appear to be one exponent rule as you do these. We use rule 6 a whole lot. Rule 1 you'll use some, even though you can just think about expanding it, and I'll try to explain that. There's no way around rule 5. You just have to know that one, memorize it. Rule 2, I really don't use it. So here we go. All this asking you to be done here is it doesn't want you to find 7 times 7 times 7 6 times and then 3 times, then multiply those together. Calculator may not even give you the answer. All it wants you to do is recognize that if you got 6 sevens here and 3 sevens there, how many sevens do you have total? The answer is 9. And that's the answer. Now if you want to use the rule, when you multiply like bases, you add exponents. If I can get around the rules, I'm going to. This one, look at the exponents, cover up that 5. It just looks like 4 times 3 because it is. You raise the power to a power, or if you have one base with more than one exponent, keep that base and multiply the exponents. Do not find 5 to the 12th. We don't want that answer. We just want what the answer is in the exponential form. Now on this one, this x cubed squared, similar to that one, you keep the base and multiply the exponents. 3 times 2 is 6. This is a commonly missed problem. Almost everybody wants to get the hang of these exponent rules will get this y value, or this y portion correct. When you raise y to the 7th to the 2nd power, you multiply the exponents because we have more than one exponent on the same base. So that'd be 14. Most people, when they miss it, they put a 4, but it's not a 4 because rule number 4 states that every base inside parentheses gets its own exponent of the outside. Now, this 4 is actually something 4 to the first, so if you want to think of it like that, that's another way. And 1 times 2 is 2, and 4 squared is 16. Most people miss that one because they leave it as a 4 and don't change it to 16 like it should be. Now, keeping that in mind, let's do this one without any work. We know that each one of these will be raised to the 3rd power. 3 to the 3rd is 27. It's 3 times 3 times 3. X squared to the 3rd, it gets its own exponent. But it already has an exponent, so when you give it another exponent, you're multiplying. And when you raise y to the 8th to the 3rd power, you're multiplying those. Now if you want to actually see the step that goes in there, here's how it would look. I'm just trying to show you that maybe some steps aren't necessary, and as soon as you can leave out some steps, the better off you're going to be. This one right here, this 3 is actually the same thing 3 over 1. We have a negative exponent, flip it over. Exponent changes signs to 2, positive 2. And we can go ahead and do this one because the numbers are so small. 3 squared is 9. This one, many people miss it. The 2 is not attached to the x, which means that the exponent on the 2 is not a negative 5. If you want the exponent on the 2, it's a positive 1. What that means is I'm not going to touch the 2. It's going to stay right where it's at. But the x with the negative exponent is going to flip to the bottom as a positive exponent. Big problem missed. That happens a whole lot. This one, it is true you can subtract. That's what rule 2 states. 7 minus 5 is 2 and you're done. I choose not to. There's a reason why, you'll find out later on. I choose to cancel in my head. These 5 x's are going to cancel 5 of those, leaving x squared. That's how I do it. These 12 3's are going to cancel 12 of those up there, leaving 3 to the 3rd. Or if you like to subtract, some of you will, and that's fine. 15 minus 12 is 3. This one's such a small number, I'm going to go ahead and multiply it out. This one right here is the main reason why I do not subtract exponents, even though I'm going to prove a point to you. You take 10 minus 15 and you do get a negative 5. Don't like negative exponents, so we got to flip it over. When we flip it, it changes the negative to a positive. Here's what I prefer to do. I like to take these 10 x's, cancel 10 of those, and at least 5 on the bottom. Remember, when you cancel, it doesn't go away, it just means it reduces down to a 1. And there's your answer. You tell me which one's easier. Now this one, as long as you use exponent rules, you cannot go wrong. And it doesn't matter which one you begin with. This one can be approached a couple different ways. Some people like to reduce inside first and then deal with the exponent on the outside. It does not make a difference at all. In fact, I may do it both ways. Let's do what's inside first. We'll just do two ways. It possibly could be a third way. We could always make up stuff too. So inside, if we reduce, those two x's cancel two of those, leaving x to the 7th on the bottom, which means there's a 1 left on top. And we're going to raise each one of these to the third power. Keep that in mind. 1 to the third is 1. That's 1 times 1 times 1. X to the 7th raised to the third power, same as x to the 7 times 3, which is to the 21st power. Like I said, these two rules tend to go together quite a bit. Tend to. Now here's another approach to this problem. Some people like to multiply the exponents first, because each one of these inside parentheses gets raised to the third power, which means we're going to multiply the exponents. 2 times 3 is 6, 7 times 3 is 21. Not bad, that's a 9. That just doesn't make any sense. 9 times 3 is 27. Don't get confused with that over there like I did. Common mistake that people make. Cancel. Those 6 x's cancel 6 of those, leaving 21 on the bottom, leaves a 1 on top. That's the answer. Does not matter what approach you take. Either way will give you the correct answer. Keep that in mind. Let's do a few more. These are fun. You're going to love these. You probably won't. Here we go. Let's do some shortcuts. Here, some people like to add. I have to think about it. 4x's there, 2x's there, 6 total. 3y's there, 1y there, 4 total. By doing that, a lot of people avoid the mistake. Some people don't realize that there's a 1 on that y. So, there's all kinds of reasons why I do what I do. This one, I'm going to deal with this exponent of 2 on the outside, which means that the 5 is being squared, which is 25. And the x squared is being squared, which means I'm going to multiply those exponents and get a 4. I'm going to put that in parentheses just to keep it separate from this other portion of the problem. Going to take the 2 and raise it to the third power, and that's 2 times 2 times 2, which is 8. And multiply those exponents and get 18, because 6 times 3 is 18. And now we're going to multiply numbers and add exponents. 25 times 8 is 200. 4x is there, 18 there, gives me a grand total of 22. Or you can just add them. This one, we got several approaches on this one. Doesn't really matter which way you go. I'm just looking at it, trying to see if I can see the quickest and easiest way. Here's what I might do. You may not. Sometimes I like to get rid of the negative exponents first, and so I'm going to work inside first. Here we go. That 3 is a positive exponent. I'm going to keep it on top. A to the 7th is a positive. I'm going to keep it on the bottom. A to the negative 4 is a negative. I'm going to flip it to the bottom. Makes it a positive. What that means is, since I have all the a's on the bottom, that's multiplication. A to the 7th times a to the 4th means, if we add the exponents, or just think about how many a's are being multiplied, there are 11 total. And then from there, we're going to take each one of these bases to the third power. 3 to the third is 3 times 3 times 3, which is 27. A to the 11th to the third power means you multiply the exponents and you get 33. That's just one approach. You can do it however you want to. I'll show you with this one the way I could have done this one. Instead of simplifying inside parentheses like I really want to here, this is really, I really and truly want to cancel this y with one of those y's. But just to show you that there's a different way, what I'm going to do is I'm going to take each one of these and raise it to the second power, even though it's not my preferred way. So I'm going to do all the steps. It'll be 3 squared, y to the 5th squared, over y squared. That's how the problem may look if you want to show all the steps. 3 squared is 9. Y to the 5th squared means you multiply and you get 10. The y squared on the bottom. Once again, if you want to subtract, you can. I don't like to. I'm going to keep the 9. Those 2 y's are going to cancel 2 of those y's, leaving y to the 8. That's how I do it. This one, I'm definitely going to flip because I don't have any like bases or common bases. So this is one of those flipping exponent problems, flipping base rules with negative exponents. This one is already positive, keep it. This one is negative, flip it. Top, it goes to the bottom. This one's a negative, it's on the bottom. Flip it, goes to the top as a positive, and you're done. Now let's try a great big one. This will be our last one for this one. Here we go. My first reaction when I look at it is immediately reduce. 3 goes into 3 once, 3 goes into 6 2 times. Just get that out of the way. And then from here it really doesn't matter. My first reaction is just to go ahead and raise each one of these bases inside the parentheses to the second power. So let's do it. 2 to the second power is a 4. X cubed to the second means you multiply. Y negative 1 to the second, we multiply. Remember that's a 1, and 1 to the second is a 1. If you want to put it in there, you can. It's not necessary. X to the negative 2 to the second power is x to the negative 4. Y to the negative 4 to the second power is y to the negative 8. Now, all kinds of ways to do this. What I'm going to do is, and I think this is probably the best way to avoid sign mistakes, is change all the bases with negative exponents to positive exponents by flipping. Watch this. I like to draw my fraction line. 4 is a positive, has a positive exponent. Keep it. X to 6, that's positive exponent. Keep it. Y to negative 2, negative exponent. Guess what I'm going to do? I'm going to flip it to the bottom. Doesn't matter where you put it. Put it on the bottom somewhere. Now let's go to the bottom. X to negative 4, negative. Going to flip it to the top. Who cares where it goes? Put it up there. Y to negative 8, it's on the bottom. Negative. Let's flip it. Flip it to the top. Put it somewheres. And the reason why I like to do this, because now I actually don't use exponent rules to do the rest of it. I have 10 x's total, and these 2 y's are going to cancel 2 of these y's, leaving 6 on top. I really don't need this fraction line because there's nothing left on the bottom. So there's my answer. 4x to the 10th, y to the 6th.